Awesome. All right. So I don't know, Julia, do you have any opening words that you might want to share?
Anna is going to start us off with the first slide.
Okay, so I mean, like just general comments.
We're really excited that everyone's here today. We're going to start off with the SEALS presentation, and then we're going to move to the Workplace Challenge. And we ask that everyone hold their questions to the end. They can put in the chat, and we can answer them at the end, or they can wait to say it verbally at the end as well.
Okay, wonderful. And Jim, how much time do you have?
Yeah, I need to leave at 4:45, unfortunately. Sorry about that. I just hopefully we can get through most of what you guys want.
Yeah, so we should probably then start right away. Arlo, as communications, do you have anything to say?
Can y'all hear me? Everyone can
Yes.
hear me? Hello?
Yeah.
All right, awesome. As communications, I guess welcome everybody. I'm glad that we're doing this. I know that there were some issues with the air quality, which meant that we weren't able to group up physically. So despite that, we had great communication throughout the whole thing. We finished up the project. It looks good. We're very excited to start the presentation.
Forward to it. Okay, I guess if no one has any other comments, let's get started.
All right, so hi everyone. I'm really excited to present you the 2023 Harbor SEALs presentation about monitoring marine debris and physical chemistry around the waters of Governor's Island. My name is Anna, by the way. Next slide, please.
So before we begin, we just want to acknowledge everyone that has helped us throughout the way of Harbor SEALs. This presentation is being submitted to Hudson River Foundation, but we'd also like to thank all of our other sponsors and stakeholders. Next slide.
I don't know if someone's presenting, but I can't hear.
Can we please move to the next slide?
Introduction. The Hudson River, known for its rich history and ecological significance, has unfortunately become a victim to marine debris. Marine debris refers to any human-made waste that enters the marine environment. Despite efforts to mitigate this issue, the presence of marine debris in the Hudson River poses severe consequences for both the environment and human health.
Marine debris is a persistent solid material that is manufactured, made by humans and disposed of in the marine environment. Riprap is a human barrier made of kind of rock material made to protect the shorelines from erosion. Our quadrat is a square plot used to mark off an area that we sample. Physical chemistry is a branch of chemistry concerned with interactions and transformations of materials. pH is how acidic or basic a source of water is, from 0 to 14, with 7 being the most neutral. And dissolved oxygen is a measure of how much oxygen is dissolved in the water. This then dictates amount of oxygen available to organisms. Next slide.
Okay, so I guess I can talk about this slide here. There's initiatives to mitigate pollution. An estimated total of 59 million was spent on marine debris waste management activities in the Hudson River Estuary. 2015, while efforts to clean up floatable debris will continue to be necessary, pollution prevention strategies are more sustainable and the rational manner of tackling the issue. Much of the debris that ends up in our waterways comes from street trash. According to the Hudson River Foundation, floatable items accounted for 66.7% of the total numbers of items collected. Cigarette butts were found to be the most numerous among all items, representing 39.6% of all trash counts and 58% of all the floatable items documented. And on average, 23.6% of all items documented were food and drink related, ranging from 41.8 to 9%. Next slide.
In 2016, plastic accounted for approximately 60% of total marine waste. Styrofoam accounted for 20%. Fishing gear and debris was 10%, and the last 10% was glass, metal, rubber, textiles, and miscellaneous items recovered throughout the harbor. This project aims to explore the negative effects of marine debris on human health within the context of the Hudson River.
All right, that brings us to our scientific problem, which is, how much marine debris is washing up on Governor's Island relative to previous sampling years?
And our hypothesis is that the tally and mass of marine debris washed up onto the riprap will decrease due to frequent collection.
The locality of where we're sampling is on Governor's Island, and we're sampling on the west side of the island.
We sample and collect marine debris from the riprap on the northern coast of the island.
All right, introducing the communications team. So our main job as the communications team is to work with the outside sources that are interacting with the harbor seals. That includes things such as stakeholders, media sources, the general public, and cooperative organizations. Additionally, the communications team also deals with the publicity of the project and its messages dispersion. On top of that, all the communications members will split up and join one of our other separate groups to help work for field days.
So this is the marine debris team. We're responsible from collecting debris from the riprap. We're equipped with protective gear such as harnesses and such to ensure safety while on the riprap. We collect debris with several different tools, grabbers, and we use buckets to collect and give it to data analysis. We continue to collect debris until the end of sampling, and we collect both generally and in designated quadrat areas. Here you see a diagram of kind of all of our safety items. So there are helmets. We have a tether connecting the sampler to the fence, wrist guards. We have shoe protection, knee guards, elbow guards, and canes to make sure everything is completely safe on the riprap.
To prepare to go onto the riprap, we have to first put on our PFDs, our life jackets, before we leave to walk to the riprap. And then we hook ourselves up we tether ourselves to the gate, and we climb a ladder, and we have to spot each other so we don't fall on the rocks or just fall in general and hurt ourselves. And then we collect the debris, whatever we find from the sample site. We place all medical waste in a separate bin. All of the debris is placed in the buckets, and we use crowbars, grabbers, or scoopers for hard to get debris.
So physical chemistry is a branch of SEALs that focuses on two things. Water tests, which is testing the water for different parameters along with logging metadata, and the drone initiative, which is getting samples further out in the harbor via 3D printed materials and flying drones.
So while water testing, we in PhysChem use a lot of different techniques, such as Winkler method test strips, and the electronic tester to find things such as temperature and pH and dissolved oxygen and a lot of different things. And our goal is to see how the water is affected and if it's affected in negative ways, and we monitor those parameters.
The main part of this for getting out into the harbor at least is the drone initiative, in which we will use the DJI Inspire 2 drone to fly out over the harbor and collect water from the harbor, but further out, which we could not do with just a bucket and a rope. Next slide, please. The main methods we do were all of these, including ensuring no people were within the takeoff radius for the drone, get the drone, get the collection cup, which was 3D printed, and grab water in it. And then we would use our multi-parameter tester to test, and we would use the Winkler method to test for dissolved oxygen on both the bucket sample and the drone sample.
Runners serve as intermediaries between the marine debris and data analysis teams. They handle the setup of the sampling site as well as the transportation of the debris between the groups. They are also responsible for practicing safety measures, which includes securing the ladder and safety lines to the fronts and practicing to use the life preserver ring.
Runners also assist the marine debris team with loading equipment onto the carts and making sure all materials from the checklist are brought with them. They then take the equipment. The equipment is then deployed from the carts to the sampling site by the riprap. We help them by putting up the ladder over the fence and securing it using a drill. Once students are safely on the riprap, we provide them with buckets and grabbers and scoopers to collect samples from the riprap. Once the debris buckets are full, we bring them over to the data analysis team.
All right, so data analysis collects the debris from the runners and then sorts them into their respective categories. Then we record the data into data tables using tally and mass. And then once those are digitized, processed, and graphed, they are then analyzed back in the lab.
Here we have the dissolved oxygen tests that we get through the Winkler method. And we have the different days and different results every day. We had to adjust our method a bit. So the random increase was probably because we found out the proper method. And here we have our pH testing, which is pretty standard, and it goes, as you can see, pretty well. And that's really it. The lowest point of pH that we ever sampled was 7.2, while the highest was 8.5. But most pH values that are recorded are around the average of 7. And we think it was probably because of the fact that we were using test strips that there was a higher margin for error. But most of the DL results were also lower than the expected averages. And when we found that out, after improving our Winkler's method, we got more accurate results.
So by the end of the year in the physical chemistry group, we were able to successfully 3D design and print a sampling container for drone sample collection, do successful drone flying and safety protocol created, successfully collect the water samples by a drone, and we also successfully updated the Winkler's method protocol to increase the accuracy of dissolved oxygen tests.
Okay,
Figures 12 and 13 show the quadrant tally data that has been collected on the west side of Governors Island. Figure 12 is a quantity of debris that has been collected from 2022, while figure 13 is the debris collected from the year 2023. Next slide. Figure 14 and 15 show the mass of debris that has been collected from both 2022 and 2023. Next slide, please. Okay. The amount of plastics collected in the year 2023 decreased to a sum of 10. The mass difference of plastics collected from 2023 was 247 grams. For mixed materials, the sum of mixed materials that was collected in the year 2022 was a sum of 8 with a mass of 308 grams, while in 2023, the sum was 2 with a mass of 62 grams. Foam was not tallied in both years. However, the mass increased from 116 grams to 1,495 grams. Next slide. An increase in organic matter in 2023 was due to the new tools that allowed us to access heavier and larger things. An increase in foam was due to the new tools that students had access to. The decrease in the other category from 2022 to 2023 is a result of more sophisticated classification methods. Next slide.
All right, so this slide represents the non-quadrant quantity comparisons of marine debris that are recovered along the riprap. And something you might notice initially is that plastics were higher last year, that the medical quantity increased by 20 to 12 debris, this year, which was really interesting. And that the smoking quantity increased this year as well. Next slide. All right, this is a non-quadrant debris mass, and also you can see that the mass stayed approximately the same here. Next slide, please. So these are just the numbers, how the mass increased and the mass difference, and you could see that the sum of the mass in plastics decreased this year, that medical increased, and that the mass increased obviously, and that smoking increased too. Next slide, please. All right, so we are assuming that less plastic weight this year could be attributed to less plastic being littered or plastic pieces being smaller from what we picked up. And because 2022 was the first year that we had been working on the riprap project, it's likely that there'll be more marine debris than any other time. So in 2022, we also had less supplies and volunteers. So the supplies we had was less optimized for marine debris collection. And this year we were able to obtain a lot more materials in order to make our process smoother.
Conclusions we've made through the data that we sampled over the course of the year has let us know that generally the 60% of the marine debris we find in the harbor is plastic. 20% seems to be about styrofoam, and the other 20% consists of all the other materials that we have graphed and sampled. Major organizations also provide the composition of marine debris found in the Hudson River. We're just also contributing to data that's going to be used for later research. And the best way that we can deal with managing marine debris in the harbor is by addressing where all of the where the major contributors are, to make sure that we can manage the waste going in the harbor and make sure that it's not going there, going elsewhere where it should be going, and promote awareness in different communities to make sure that their process of waste management is correct. and following regulations that won't lead to more pollution and more debris being in the harbor.
So we just want to talk briefly about some of the outreach that we've done this year and last year. So this is some stuff that we did at the end of last year and the beginning of this year with Earth Matter. We made that cube with Earth Matter that is separated into different categories of marine debris that we have collected. And we also did an art exhibit with NYU Gallatin about marine debris and how it's interconnected with climate change. Next slide. These are just some of the kind of posters we made and art we did. Thank you.
Another example of outreach that we used was this brochure that essentially just talks about what the RipRap project is, Harbor Seal's story and our purpose. And it's just something we've been handing out to a lot of people just to raise awareness about the marine debris in the harbor and what we're doing to help.
And this is when the Harbor Seals went to go visit the Netherlands consulate, where we got to show off the work that we've been doing, its impact on the world, and some other really cool information that we learned from this program. Then we just have some photos of us in the program. And then we have our bibliography. All right, so that's the end of our presentation.
Okay, thank you so much, Arlo and Julia and all the other students that presented. This was pretty awesome. Let's open it up to some questions. I know that we might want to take a look at some of those graphs potentially and to see some of the major differences that happen. Yeah, good. Maybe we can take a look at the changes here in the tally. So we broke things up into non-quadrat and quadrat. Does somebody want to explain that? I don't know that that was explained in the methods. Can somebody explain the difference between the quadrat and the non-quadrat data sets?
Sure, I can explain, but do you think we could possibly do this after so the juniors in the workplace challenge could have time to present? Because we just want to make sure that they can present before. Sorry.
Yeah, well, this is a quick explanation, and then
Okay,
after
yeah.
this one, we can jump over to the.
Sure, I can explain this really quickly then. So we did 3 quadrat samples where it's the meter by meter box where we sample from one specific area. We only did that 2 times this year, so they were sampled in a 6-month period in between, and then the non-quadrat was just generally all throughout the riprap and not in those 3 specific areas.
Yeah, and why use a quadrat? Like, what's the purpose of using a quadrat for some of the sampling?
In order to monitor a specific area that we had picked out. So last year we randomly selected this meter by meter area. So revisiting that area, we're able to see the differences in how it looks, what washed up, specifically what kinds of materials had washed up that weren't there last year or ones that were there last year. So it just gives us more of an idea of how things have changed between those 6 months of sampling.
In a specific area, right?
Yeah.
Thank you. Okay. Whenever you're ready.
All right, I'm gonna stop screen sharing so the juniors can get on.
Microplastics, tiny plastic, big problem.
My name is Brenda Hinaro.
My name is Christopher Tranquina.
I'm Nine Smith.
My name is Josiah Taylor.
My name is Madison O'Brien.
My name is Mark Garcia.
My name is Elias Littman, and this is our presentation on trends in plankton and microplastic concentrations in the Hudson River estuary within the past 2 years.
So in this presentation, we will be discussing the process of sampling for our data. So we'll be talking about how we use the beta bottle and the challenges that we face while using them. We will then analyze the data that we found and we'll compare it to the previous data that we've had over the past few years. And you're probably wondering why this research is important. Well, we're trying to bring more awareness to any pollution that is going on in the harbor. And we're also trying to learn more about the current health of the harbor.
Here we can see where we sampled in 2022. And here we can see where we sampled in 2023.
Studies have shown that microplastics are in waters around the world, such as Mongolia. And in 2016, New Jersey Baykeeper found over 250,000 microplastic particles.
So here's some background information about the topic we're going to be discussing about. So microplastics and other debris can be harmful for marine organisms. Sometimes marine organisms might ingest or sometimes they might ingest or absorb microplastics or microdebris which harm their digestive systems. Microplastics can also infiltrate our water and we could end up drinking them, which could be overall bad for us. And determining the concentration of plankton can tell us more about the health of the harbor as they're very key to the ecosystem. And lastly, the increase of plastics displace plankton, lowering their population. This is very important as we use this to develop our hypothesis.
This takes us into our scientific problem, which is, has there been an increase or decrease in concentration of plankton and microdebris in the past 2 years?
We hypothesize that there would be an increased concentration of plastics because plastic production in general has increased in the recent years, leading us to believe that there will be a decrease in the plankton population.
All right, so some of the methods that we use to measure water quality. For dissolved oxygen, we use the Winkler method. To measure pH, we use an aperimeter. For nitrate, and alkalinity, we use test strips. And then for the Secchi depth, we used a turbidity tube. And finally, to measure salinity, we used a refractometer.
To actually obtain our samples, we used a beta bottle, which was lowered 1 meter under the water's surface. And then a messenger was sent down to activate the beta bottle, collecting our sample. We then retrieved the beta bottle and took a 100 milliliter sample in glass Pyrex bottles and added Lugol solution until the sample turned amber, which preserved our sample. When we got back to the lab, we added these samples to graduated cylinders and stored it in a dark place overnight to let the plastics rise and the plankton settle. We then took a 1 milliliter sample from the top of the graduated cylinder and placed it in a Cedric Rafter counting slide and viewed and recorded the plastics found it. We then took 89 milliliters of the sample out of the graduated cylinder, leaving 10 milliliters behind. We homogenized those 10 milliliters and used a pipette to place 1 milliliter into a Cedric Rafter counting slide. We observed that under a microscope and used the equation below to translate the 10 milliliters up to 100 milliliters. So the 10 milliliters was basically became as if we sampled from 100 milliliters.
Now, when we conducted our research, there were some risks that came along with it, specifically in the form of chemicals. Some of these chemicals come in the form of sulfuric acid, alkaline potassium iodine azide, sodium thiosulfate, formalin, and iodine. Some of the lesser ones, but still dangerous, are starch indicator and manganese sulfate solutions. And to overcome these risks, we use proper personal protection equipment in the form of rubber gloves, flotation devices, as to not fall off wherever we were sampling, protective eyewear, and lab coats.
I can't hear.
Sorry, I was mute. Sorry, I was muted. I'm sorry. Here we have different concentrations of plastic we found in the study. We looked at microfoam, microplastic paint chips, and microfibers. We compared 2022 with 2023. And on our left is an image taken from our colleague Chris that found microfiber. We found that in 2022, there was an increased amount of microfiber than in 2023, and in 2022, there was a high concentration of microfoam at 37.5 per milliliter, followed by microfiber at 26.6 per milliliter. We found that in, wait, can you go to the next slide? We found that in microfilm is likely from single-use products such as takeout boxes and coffee cups. Microplastics can result in the breakdown of larger plastics and are intentionally manufactured, such as microfibers that are especially common in textiles and cosmetic industries.
Another type of particle we sampled for was plankton. This plankton came in the form of unicellular, colonial, filamentous, macrophyte, and unidentified plankton. And the image to the left of our graph, we see one of our colleagues took a picture of a string of colonial plankton within one of the samples. The results are as shown, and we discovered that there was a significantly lower amount of plankton when we compared years 2022 to 2023. And the biggest difference in both of these years was the amount of unicellular plankton we found. This is due to two reasons, one of which could be that the flow of plastics into the harbor displaced the plankton, and the second one would be that the rise of the sea level created a layer between nutrient-rich water and warm and very low nutrient water, causing the planktons to be deprived of what they need to survive.
And if you look at the figure here, you can see the very obvious trend. So what I was saying was that if you look, you can see, if you look on the figure here, you can see the obvious trend that on both years 2022 and 2023, both plastics and plankton, 2022 has an extraordinary higher amount than in comparison to 2023.
So with the collected data, with the collected data that we find, we could conclude that there was a positive change in microplastics and a negative change in plankton. And we could use it as an indication as there's less plastics making their way into the harbor. However, there's still some plastics making their way into the harbor, as in our literature review, we found out that plastic production displaces the plankton, which is why we have a lower plankton count this year. However, there are some errors that could have happened in our data, such as in 2022, we were less experienced, and we were also less experienced in identifying plastics and plankton, but we believe that our data is mostly correct.
Improvements for future research, better following of the established methods and process of our data sheets, and better identification on plastics and plankton.
These are all our sources where we got our research from.
Thank you for coming to our presentation on trends in plankton and microplastic concentrations in the Hudson River estuary in the past few years.
All right. Thank you very much. You folks did an amazing job pulling all of this work together this past year. I really have to commend you all. I am super impressed as a teacher in general, and your teacher specifically. And also that this is a lot of this information was collected by after-school students in 9, 10, 11, and 12th grade, and also by our juniors in the workplace challenge. So let's open it up to some questions that our guests may have, or any of the participants. And I know that, Jim, you need to leave in 6 minutes. So do you want to ask the first question?
Yeah, no, that's great. Well, first, I'll just echo Mauricio's comment that this is really, really impressive, and thank you for all your efforts, and for this presentation is really well done and very impressive. Maybe just think, starting with the microplastics, were you guys surprised that variation between the 2 years? It certainly struck me as very really high, and I guess if you were, can you sort of talk a little bit about why you think that might be. I know you said you know that you had some experience that might have changed over time, but the methods were essentially similar. So I guess it's a question back to you guys. Do you think it could be that the sites are very variable, that there's timing that changes year to year or day to day that might be influencing that? Again, that sort of very high variability that you guys observed.
Well, the two samples were taken in two different seasons. I think one was taken in winter and one was more closer to spring. So I think the difference in seasons is what really led to the big gap in the data we found.
And also, sorry.
No, go ahead.
Another variable could obviously be weather, tides, anything that can alter the harbor would definitely make an effect that like you can see in the tallies of plankton.
Yeah, I mean that's a great observation. I was thinking the same, that maybe it'd be interesting to think about how like maybe how proximate to a rainfall event it was, like, right? Because if you had a big CSO events, do we see more microplastics, for instance, in the water? I actually don't know the answer. That would be my assumption, but there's probably a lot of other variables as well.
Yeah, and I'd like to jump in and just say that I think, like any other environmental monitoring project, I think that as we improve our technique and as we sample for the next X amount of years, that our accuracy and precision will hopefully improve, and the trends we'll be able to see. If you can imagine, like, having 10 years worth of data, maybe we'll come to find that 2023 was just a very odd year versus 2022 or vice versa. So I think that long-term data for monitoring is definitely necessary, and the improvement of our technique.
Yeah, no, that's great. So maybe just another question on the marine debris project. Along similar lines, that you guys saw less variability between the 2 years, if I remember correctly, which is interesting as well, right? But I guess thinking about that, were you surprised that you didn't see a lot of variability? And then maybe a follow-up would be, how do your results compare to other studies in the region? You mentioned like EPA and Riverkeeper and NOAA have studied. And so did you, like, in terms of the groupings of the marine debris, was it similar to those other studies?
I don't think that we were surprised by how little variability there was. I think that that's kind of what we expected to come back up. It was pretty similar to what other studies within the area had found, but it was a little different. I can't remember. I feel like we got more foam and we got a lot more metals and those kind of miscellaneous things that weren't really expected. I know that we got similar amount of plastics. We got a lot of plastic, but besides that, it all kind of fit into what we had expected from last year and what we're expecting to see in the next few years.
That's great. Thank you.
Thank you. Actually, I'd say the only thing we were surprised about was that there were more medical things this year than there were last year, considering COVID and considering all that. We expected a lot more to be there last year, but it makes sense why this year they're washing up actually and have made their way to Governor's Island. We found a lot of needles this year, which was really surprising and a little bit scary, but yeah.
Did you find like masks or?
Yes.
Yeah.
We found not too many, but enough that we noticed like that those wouldn't have been there a few years ago when COVID did not exist. I think we found around 5, but it was really interesting to see the thing that we'd been wearing for like the past 3 years washed up on the island. So yeah, and I guess of course, like wonder where those came from and how they got to the island itself. So that's something we're continuing to think about, where the source of all these things are coming from. And we're finding brand names on stuff and seeing if we could reach out to them and their consumers. So
Great. I get, one hypothesis could have been you would see less marine debris because you have less people in the city, right? Who left COVID, but you guys
Mhm.
didn't see that, which is also
yeah,
interesting.
that makes sense. Yeah. A lot of people have been moving out. So, all
Well, thanks again, guys, and I'm sorry I have to jump off, but super impressed, and again, thanks for presenting.
Yeah,
Thank you
and
for being
before
here.
you go, Julia just shared the document.
Okay, great.
If you wanna pull that one up quickly, and we're also gonna send this to all of you. So thank you so much.
Yeah, no, thank you again, guys. Have a great day. Bye.
Awesome job, everybody.
Thank you.
Have a wonderful. We'll see you tomorrow in virtual. I'll send out some information tonight about how we're gonna finish up presentations. All right.
Awesome. Thank you, everybody.
Thank you, everyone. Have a great day.
You too.
Thank you.
Bye-bye.
Thank you. You have a
Thank
great
you.
day as well.
Bye.